Hey, thanks for clicking on the video and spending a few minutes with me to check out the Cooler Master MasterFrame 500 Mesh. If you're looking for a solidly built, high airflow enclosure that's modular and fully customizable for your next PC build, this one might be worth a closer look. The MasterFrame 500 is the next evolution of Cooler Master's Freeform 2.0 platform, a slightly smaller but more modular take on the original MasterFrame 600. Today, I'll walk you through the specs and features of the 500 mesh and show you exactly what kind of hardware it can support. We'll break down the build quality and materials, and if you haven't noticed already, this unit isn't exactly in its stock configuration. I've taken it apart, reconfigured it, and I'll show you just how far this case can be broken down and what it took to reassemble it. Once it's back together and loaded with my test system, I'll walk you through its thermal performance, and we'll wrap things up with my final thoughts on the MasterFrame 500 mesh. Let's get into it. It's the money. The MasterFrame 500 mesh is part of Cooler Master's modular MasterFrame series and comes in both black and silver finishes. It measures 471 by 261 by 544 millimeters with a total volume of 66.9 liters. It supports everything from mini ITX up to SSI CEB motherboards. Cooling support is both generous and highly configurable. The case comes pre-installed with a pair of 200mm sickle flow fans up front and a single 120mm fan in the rear. If you want to customize that setup, there's room for up to 3 120s, 2 140s, 2 180s, or 2 200mm fans in the front. The top and optionally the bottom can also support up to 3 120s, 2 140s, 2 180s, or 2 200mm fans. Radiator support mirrors that layout with up to 360mm rad supported on the front, top, and bottom. Just keep in mind a bottom mounted radiator only makes sense in an open loop setup. Aside from the mesh panels themselves, there are no secondary dust filters anywhere in the case. Clearance won't be an issue for most builds. There's room for up to 190mm tall CPU coolers, a GPU up to 425mm long, and power supplies up to 235mm deep. Storage options are limited to a single set of modular rails that can hold either a 2.5 or 3.5 inch drive. So if you're planning a build with a lot of internal storage, this probably won't be the best fit. Right up front, there's a simple but modern IL layout, 2 USB 3.2 Gen 1 Type A ports, one 3.2 Gen 2x2 Type C, a combo audio jack, and a power button. Around back, there's a full 8 PCIe expansion slots. Cable routing space behind the motherboard tray is roomy, 43mm, and Cooler Master includes a GPU support bracket, and if you go with the ARGB version, you also get a PWM ARGB hub in the box. Construction-wise, the MasterFrame 500 mesh is solidly built. The left side panel is 4mm tempered glass, while the right panel is a thick slab of 4mm aluminum. Both the top and front panels are made from SECC mesh steel, and for convenience, all of those panels are magnetically attached, no tools needed to pop them off. Once the panels are off, the whole thing starts to take on an industrial look. The external frame, made up of 8 corner pieces and 12 cross members, is constructed from sturdy, media blasted and anodized aluminum. The entire frame is riveted together. It's extremely rigid, but that also means there's no flexibility to reconfigure the frame itself like we saw in some of the early design concepts. You'll find all the steel modules and brackets that hold your actual PC components, the motherboard tray, PSU shroud, PCIe expansion bracket, and cable shroud, are either screwed directly onto the frame or mounted to the steel crossbars, which are then attached at one of the many available mounting points. There are 2 steel crossbars originally mounted at the top of the case. I moved them to the bottom to mount the fan setup. The front fans are secured using modular steel brackets that can be rotated or flipped depending on the fan size and configuration you're going with. Now, up to this point, the MasterFrame 500 probably seems like any other solid, well-built mid-tier ATX case, and it is, but once you get your hands on it, the mechanical modular design becomes both a blessing and a bit of a curse. If you're into that industrial no-nonsense aesthetic and the satisfaction of building something that feels engineered rather than molded, it delivers, but it also brings a few frustrations along for the ride. Like I mentioned earlier, this isn't how the case came out of the box. The stock layout is pretty typical. PSU shroud at the bottom, rear motherboard tray above that, rails up top for fans. I tore it down immediately, stripped it to its base components, and rebuilt it with a few changes. I moved the PSU and front I/O to the top of the case, which meant pretty much disassembling everything. The PSU shroud and bracket went up top, the rear panel and motherboard tray slid down, and I had to lower the front fans to make room for the I/O. I really wanted to install the I/O panel on the roof, just like on the MasterFrame 600, just to keep the front clean and mesh only, but the top and front panels are identical in size, and without a shorter top panel, that just isn't happening. One thing that tripped me up, the case uses two different size screws, M4 and M3.5, to secure all the panels. At first glance, they looked identical, and I didn't catch the difference, so yeah, there may have been some colorful language during reassembly. Come on. Then there's the PSU shroud. To install it upside down, I had to remove the rear panel completely, but there's no way to reattach it after flipping the PSU shroud. So now all the rear cables are just hanging out in plain view, and it doesn't seem like there was much thought given to cable exits with the PSU mounted up top. There are two pass-throughs, one larger and one smaller, and while I could route the 8-pin EPS cable through directly to the motherboard, the big one, the 24-pin ATX cable, when it fit through the smaller pass-through, even if it had, there's no path to run it behind the motherboard tray. I had to route it over the top of the cross member, and that only worked because I'm using a flat cable. A braided one, like many non-modular PSUs come with, wouldn't have cleared that gap. I had the same issue with the PCI power cables. Even though my PSU includes standard length cables, they wouldn't reach the GPU. I had to use extensions. Same with the front I/O cables. I had to drag them across the middle of the case just to make the distance. Even then, the USB Type-A cable couldn't reach the motherboard header, and the front audio cable only did because I'm using a micro ATX board. If you're building with a full ATX, that cable's not making it. I also discovered that with the motherboard tray lowered, the included GPU bracket wouldn't adjust low enough to fit under my 3-slot RX 9070 XT. Now, I get it. None of this would have been a problem if I had just left the case stock, except, well, I did find that the GPU support bracket can only be installed in a narrow area where it doesn't interfere with the panel latches. But the whole point is that it's supposed to be modular and reconfigurable. I followed one of Cooler Master's build guide examples. That idea, a single case you can reshape without drilling out rivets or cutting metal, is something I absolutely love as a builder, but the execution here misses the mark. No discrete cable exits for a top-mounted PSU, I/O cables that don't reach, two nearly identical screw types, and that just makes assembly frustrating. Cooler Master even showcases an extreme reverse inverted concept, and I decided to try something similar. I rotated the case 90 degrees so that the rear became the bottom, then reconfigured the panels for a full inverted layout. It looked awesome at first, but the first problem I ran into was that there's no way to attach the feet to the I/O side because the mounting holes are blocked by the I/O panels, and when you just set the feet under it for balance, you immediately notice the second problem. There's only 15 millimeters of clearance underneath, so good luck plugging anything in. So for overall design, I give it an A for concept, but execution, that's a C-. But did my reconfiguration, which added some extra airflow to the GPU, along with those massive 200 millimeter front fans, actually improve temps? Well, yes and no. I ran the system through 3 20-minute gaming sessions and averaged the results, comparing it to both my open air bench and to the case in its original configuration. In the top-mounted PSU setup, CPU temps dropped by about a half a degree, basically nothing. However, opening up the top of the case and letting the positive pressure push hot air straight out gave the best results, with CPU temps dropping 3.4 degrees in its original configuration compared to the open air's test bench. Surprisingly, even with 3 bottom fans installed, GPU temps still rose by 3.4 degrees in the top PSU layout, compared to a 2.3 degree increase when the PSU was mounted below the card. Once again, it seems that giving hot air a way to escape does more than just adding extra airflow. VRM temps were the most consistent, dropping by only 2.3 degrees in both setups. Not terrible, but not what I'd call a win. Now, something I don't see talked about enough in case reviews is VRM temps. If you've been building systems a while, you know the motherboard is usually the first component to fail unless you cheaped out on the PSU, in which case all bets are off, but let's assume you didn't. It's the power delivery components on the board that wear out first. The VRMs made up of MOSFETs, chokes, and caps. These parts have a rated lifespan that are directly affected by heat. A typical mid-range MOSFET might be rated for 10,000 to 30,000 hours at 100 degrees Celsius, but thanks to the Arrhenius equation, we know every 10 degrees drop in temp doubles that lifespan. So taking VRMs from 100C down to 60C can stretch their usable life from a few years to over 2 decades. And that's not theory. That's the kind of long-term reliability you want when you're building a system you plan to keep. In this layout, though, the top VRM heatsink sits directly under the PSU shroud, and it gets almost no airflow. I typically see at least a 5-degree drop with proper airflow, so clearly this config isn't doing it. Cooler Master could have added some vents to the PSU shroud that would have let me flip the PSU and use it to exhaust warm air off the VRMs and relieve some of the positive pressure buildup. And if you're using a gold rated or better PSU, the added thermal load isn't really going to be a problem. I've been building PCs since the 90s, so yeah, I'm old enough to remember when exhausting heat through a top mounted PSU was peak airflow design. And yes, I'm also fully aware that saying that probably just aged me out of your recommended feed. But moving on, it's also worth noting 200mm fans can move a ton of air in terms of volume, but their static pressure is usually pretty weak. Any obstruction, like the mesh front panel, can tank their performance. When I removed the front panel and reran the test, CPU drops by another 2 degrees, and both GPU and VRM temps came down slightly as well. Now, if you're building for thermals, my testing showed the best bang for your buck is to stick with the original configuration and add a triple pack of quality static pressure 120 or 140mm fans. Mount 2 up top with the top rear as an exhaust and the top front as an intake, and place the third in the bottom as an intake. This creates a pressurized airflow path that feeds the CPU and GPU coolers while also pushing heat out of the case. Avoid using both top fans as exhaust because the front one will mostly just rob airflow from the CPU cooler. With this setup, CPU temp stayed roughly the same, but still over 3 degrees better than open air, but GPU temps dropped 1.7 degrees compared to the open air results, the first result beating the test bench, and MOSFET temps fell 5.8 degrees below what I saw on the test bench. The results are now in line with what I'd expect from an airflow focused case of this volume. On the plus side, when it comes to noise, larger fans are still a win. They can move the same amount of air as smaller ones, but at much lower RPM, which means they're naturally quieter. In stock configuration, total system noise under gaming load measured just 47.4 decibels, quiet enough to fade into the background. Adding the 3 140mm fans brought it up to just 49.6 decibels, keeping it just under the 50 decibel mark I aim for in my builds. So for what's supposed to be a smaller version of the MasterFrame 600, the 500 mesh is still a massive case, especially for something marketed as a mid-tower. That said, the build quality and materials probably justify the size and the price, and I'll admit, I really like the silver and white colorway. I've got a bunch of matching components that would look incredible in this case. Unfortunately, the only large white GPU I have is still out for RMA, so maybe next time. Conceptually, I love what Cooler Master is doing here. Huge credit to the designers and engineers for pushing boundaries on modular case design. And if you're like me, that idea probably speaks to the PC building enthusiast in you too, but there were some crucial extra steps that just didn't happen. A bit of real world feedback from people actually building systems would have caught the layout issues I ran into and probably many more. And Cooler Master isn't short on resources there. They host the Case Mod World Series every year and have connections with some of the best builders in the world. As it stands, this case is gonna appeal to a very specific type of builder. It's a niche product today, but with some more refinement and thoughtful iterations, I could absolutely see the MasterFrame concept becoming a serious player in the mainstream PC market. If you found this helpful, do me a favor and hit that like button. It really does help more than you might think. And if you want to see more honest, in-depth reviews like this, consider subscribing so you don't miss the next one. Thanks for spending some time with me today. I appreciate it, and I'll catch you in the next video.